All right, we're moving on to the 2.6 notes, again, where we're solving equations with variables on both sides. So as you see here, we have the steps for solving equations. Again, the goal is to get the variable on one side of the equation by itself. So we should be very familiar with this box of information because this is the third time we've seen it in this notes packet. Well, let's review it again, right? Number one, we should be looking to clear out all fractions if there are fractions in our equation. And we do this by multiplying each term in the equation by the common denominator of all fractions involved. Number two, to simplify both sides of the equal sign. Again, we're doing things like distributive property and combining like terms. And then finally, we need to isolate the variable on one side of the equal sign. And then we undo any addition or subtraction. We undo any multiplication or division. And always knowing that sometimes not all of these steps are going to be used. All right, so take a look at example number one. So now we have equations where there are variables in more than one spot. And here we have variables in two different places on opposite sides of the equal sign. Okay, so again, we're thinking about the three steps that we mentioned a few seconds ago. Again, we're thinking about clearing out fractions. Well, there aren't any. Simplifying each side of the equal sign. Well, on the left side, it's just a 5x minus 3. There's nothing to distribute. There's no like terms to combine there. The right side, 2x plus 6. Again, nothing to distribute. No like terms there. So we're moving on to step 3, which says we want to isolate the variable on one side of the equal sign. So here, we can have x on opposite sides of the equal sign. So we need to decide where we want our variables to be located. All right, so let's say we want to get all our x's to the left side of the equal sign. So that means that this 2x right here, right, that 2x needs to be moved to the opposite side where the 5x is. All right, so to move it, we're going to subtract 2x from both sides. Again, doing the opposite. Showing all the work here. So now I have 3x minus 3 equals 6. We have isolated the variables to one side of the equal sign. Now we start to undo operations to get the variable totally by itself. Add 3. And then do the opposite, divide by 3. Part B. Again, we see variables on opposite sides of the equal sign. So we need to bring it all to one side. So maybe here we'll bring the variable off to the right. So I will get rid of this 8x that's on the left by adding it to both sides. Now we have the variable located only on one side of the equal sign. So now we try to isolate. So once we got x equals 2, then we know that we are done. Now let's see what you can do with part C and D. Again, when you have variables on both sides of the equal sign, you want to try to get them all to one side. So again, for part C, maybe you choose the left side as where you want to keep your variable. So we'll subtract 3k from both sides. So now we have the k on the left side of the equal sign. So then we work to isolate the variable by undoing operations. So you should have got k equals 1. Again, it doesn't matter what side you decide you want your variable to be on. Again, if you have it on two different sides, you can choose either the left or the right. So for part D, I chose to have the x's on the right this time. So again, I'm going to subtract 4x from both sides. So now I just have the variable on the right side. So undoing the operations to get x by itself, I got x is equal to -4. Looking at example 2, now again we have variables on both sides of the equal sign, but in some of these equations, right, we have to do more than just undo operations. So looking at part A, you see that while there are no fractions to clear, we definitely have on the right side of this equation some simplifying that we need to do. Right, we got to distribute that 2 through the parentheses. So when we do that, we get 2x plus 4. Now with both sides of the equal sign totally simplified, now we go ahead and think about getting all the x variables to one side. All right, so again, we're going to subtract 2x from both sides because I want my variable to be on the left. Undo operations to isolate the variable. We get x is equal to 11/3. Moving on to part B. Again, we got a variable on both sides of the equal sign. So again, we're looking to get it on one side. So again, maybe this time we will move the variables over to the right. So we're going to add 3m to both sides. Then we get 24 is equal to 8m. Isolating the variable, get m by itself. So we're going to undo the operation of multiplying by 8 by dividing both sides by 8. And we get m is equal to 3. Now when you're solving these equations, we cannot forget about the 3 steps we mentioned numerous times in this packet. Number 1, we need to clear out all fractions if we have any. Well, for part C, we don't have any. Step 2 says that we need to simplify each side of the equal sign first. Again, before we undo any operations, we need to make sure the left side and the right side of an equation is totally simplified. That means you're doing things like distributive property, or like in part C, right, you see on the left side, we can combine like terms. So I'm going to combine the 8w with the -6w to get 2w. Right? Before we start undoing operations, before we start getting the variables all over to one side, make sure the left side and the right side of your equation are totally simplified. Now that we have the left side as simplified as it's going to get, 2w minus 8. The right side, as simplified as it's going to get, 4w minus 7. Now we can go ahead and decide, hey, I want to move the variables over to one side and then isolate the variable by undoing operations. When it's all said and done, when we're solving for w, usually w is equal to -1/2. All right, we skipped over here to example number 3, part A. Again, we're looking to solve for x. Step 1, we're thinking, let's clear out fractions. We don't have any. Step 2, simplify each side of the equal sign. All right, well, we do see x's in more than one place. All right, we're not going to undo any operations yet. We need to simplify that left side. When we distribute that 4 through the parentheses, we get 8 minus 4x. Still not completely simplified on the left side. We need to combine like terms. When we combine the 3x and the minus 4x, we get negative 1x plus 8. Now the left side is totally simplified. The right side is totally simplified. Now we start to undo operations, getting the variable off to one side and then isolating that variable, solving for x. For me, my personal preference is always to have my variable on the left side of the equal sign, and it doesn't matter which side you decide on. But again, for me, I just like to have my variable off on the left. Okay, so if you make your variable be on the right, then your step's going to be slightly different from mine. Again, undoing operations to get the variable by itself. It's all said and done. You should get x is equal to 3/5. So now let's move on down to the U-try for part C. Let's see what you get for part C when you're solving for the variable a. All right, let's check to see how you did. Again, on the left side, got to simplify first. So we got to distribute that 5 through the parentheses to get 5a plus 15 minus a on the left. On the right, got to distribute that negative 1 through the parentheses. So it's negative 4a plus 6 and then the plus 1. Still not done simplifying on the left. Combine like terms to get 4a plus 15. On the right side, again, not completely simplified. You could combine the 6 and the 1 to get negative 4a plus 7. Now that both sides of the equal sign are totally simplified, now is the time to go ahead and start to undo operations. So again, I bring my variable over to the left. So on the right side, I'm going to add 4a to get rid of it on the right side there. I'm going to add 4a to both sides. So now on the left side, I have 8a plus 15. On the right side, I have a 7. Isolating the variable on the left, I'm going to undo operations. Subtract 15 from both sides. I get 8a equals negative 8. Divide both sides by 8 to get a is equal to negative 1. All right, let's try one more time here on your own. See what you can do with part D, solving for z. Left side, got to simplify first. So we're going to distribute the negative 4 through. So we got negative 8z plus 24. On the right side, got to distribute at negative 3 first to get a negative 3z plus 12, and then that plus z at the end. The left side is simplified, right? Negative 8z plus 24. Can't do anything else with that. But the right side, we can combine like terms. Negative 3z plus z gives me negative 2z, and then plus 12. Okay, so now that both sides are completely simplified, I want to look to undo operations. So I'm going to first bring my variable over to the left by adding 2z to both sides. So now I get negative 6z plus 24 on the left equals to 12. Undoing operations to get the variable by itself, I finally get z is equal to 2. All right, that's it for today's lesson. If you have any questions, make sure you ask. Go ahead and move on to the 2.6 homework.